So, hello all students, very good evening to one and all present here and welcome to Enlightened Educators. So, today we have come up with a live on mission analysis concept. So, actually today was free, so I'm handling that. So, from now on, so I'll be handling one session on weekdays, right? In any of the weekdays, I'll be selecting which weekdays I'm free, I'll be handling the session, and on Saturdays and Sundays, we'll be having more and more sessions. Okay, yeah, so from now on this is my plan, and this is my time schedule for you all. Okay, weekdays whenever I'm free I will take that, any one of the weekdays. Weekends it is on Saturdays and Sundays. Okay, yes. And one more thing I have to tell you, actually there is star to delta transformation, as you all know, right? You have star to delta transformation, as you all know, but I'm not taking up star to delta transformation right now. It is because why I'm not taking it up is because that is of good importance only, but I'll be taking up that in a later section. So now let us take up with respect to mesh analysis. Fine. So you already know why the mesh analysis is being introduced to you, right? Mesh analysis has been introduced as because you know that if you have a complex circuit, say there are several number of sources and several number of elements, several number of like sources, say voltage and current sources, as well as several number of components like resistance, inductance and capacitor. So that complex circuit whatever you have, you can't solve using star to delta transformation, right? Each and every what I can say, the methodology is being introduced because of the disadvantage of the last one, right? ಸೊ ನೀವು ಯಾವುದೇ ಒಂದು ಮೆಥಡಾಲಜಿ ಅಥವಾ ಯಾವುದೇ ಒಂದು ಡಿವೈಸ್ ನ ನೀವು ತಗೊಂಡಾಗ, if you take device in any of your theoretical concept, so that device has been introduced. Why? Because there is a disadvantage in the before device, right? Before there was a device being introduced wherein there are some disadvantages in that device, and to overcome that disadvantage in the device we are introducing a new one, right? The same thing over here. Okay, so it is like in star to delta transformation, you just apply the formula and do it. But for the complex circuit which is having more and more, what I can say, the this one, which one, more and more sources, say voltage and current sources, as well as if you have more and more components, say resistance, inductance and capacitance, you need to go for another alternate method which can suit this, right? So that is what is a mesh analysis. So mesh, what I can call it as, it is a electrical circuit. Okay, it is a closed path. What? It's an electrical circuit and a closed path. And you can also call a mesh as a loop, right? Mesh as a loop, and you have to know that all the mesh is a loop and all the loops are not meshes. What is mesh? First of all, mesh is a loop, right? But loop is not a mesh. Okay, yeah. And the second thing is that it is a closed path. Mesh is a closed path. It is not an open path, right? So why mesh is a loop and loop is not a mesh is because you know that mesh is a loop wherein it doesn't contain any other loops inside it. So you have a mesh like this. So let me consider this as voltage, and this as their resistances, and this as their resistance. Now if I consider this as a mesh, just a minute. Okay, now if I consider this as a mesh, then, or this as a loop, this, in this loop, can you see any other extra loop? Can you see any other extra loop or sub loop inside that loop? No, right? So that is why mesh is a loop, but loop cannot be called as a mesh. Okay, yeah. So these things you got to know. Mesh is a closed path. Mesh or a loop is also called as a loop. No, so that is why mesh or a loop is a closed path wherein what? Wherein there is no other loop present inside it. Okay, yeah. So let us see the general diagram of the mesh analysis and what I can say the steps to follow the mesh analysis. Today we are going to discuss that much, and we are also going to see what is super mesh analysis also in a simple manner. The same process that you follow for mesh analysis, it is also the same for super mesh analysis. But what is that you're supposed to do is you have to just do some modification. I'll tell you what. And today I just had a small check wherein I got to know that the scheme of valuation what has been released by the VTO, that is a question paper attached, answer script attached with your question paper. Say the key answer key attached with the question paper is not being used by most of the students, right? Is not being used by most of the students, or most of the student doesn't know about it. So I felt like very sad. Okay, I felt very bad really, because that is very important for you all students. I told you why. And many of the students are not using it, or many of the students doesn't have any idea, or college people are not giving them any idea, it seems. So that is why what does the matter is, if you want idea on that, please to follow our channel to get more and more ideas on scheme of valuation, more and more ideas on why it is very much important, right? So ನಿಮ್ಮ ಕಾಲೇಜಲ್ಲಿ ಆಗಿಲ್ಲ ಅಂದ್ರೆ ನಮ್ಮಲ್ಲಿ ಆಗತ್ತೆ, ದಯವಿಟ್ಟು ಚೆಕ್ ಮಾಡಿ, ಓಕೆನಾ? ಸೊ ದಟ್ ಇಸ್ ವೆರಿ ಮಚ್ ಇಂಪಾರ್ಟೆಂಟ್. ಸೊ ಯಾ, ಐ ಜಸ್ಟ್ ಹ್ಯಾಡ್ ಅನ್ ಆಪರ್ಚುನಿಟಿ ಟು ಚೆಕ್ ವಿತ್ ದಟ್. ಸೊ ಐ ಗಾಟ್ ಟು ನೋ ದಟ್. ಸೊ ದಟ್ ಇಸ್ ವೈ ಇದನ್ನ ಬಳಸ್ಕೊಳ್ಳಿ, ತುಂಬಾ ತುಂಬಾ ಹೆಲ್ಪ್ ಆಗುತ್ತೆ. ದಯವಿಟ್ಟು ಯಾವುದೇ ರೀತಿಯಿಂದ ಮಿಸ್ ಮಾಡ್ಕೊಳ್ಳೋಕೆ ಹೋಗ್ಬೇಡಿ. ಎಷ್ಟು ತರ ಉಪಯೋಗ ಆಗುತ್ತೆ ಅಂತ ನಾನು ತುಂಬಾ ಸಲ ಹೇಳಿದೀನಿ. ಇವಾಗ ನಾನು ಅದನ್ನ ಹೇಳ್ತಾ ಟೈಮ್ ವೇಸ್ಟ್ ಮಾಡೋಕ್ಕಾಗಲ್ಲ. ಐ ಹ್ಯಾವ್ ಟು ಡೂ ವಿತ್ ದಿಸ್. ಫೈನ್. ಓಕೆ. So let me draw the general diagram for the mesh analysis, and let me tell you what are the procedures that you have to follow for mesh analysis, solving the mesh analysis. And this is a simpler session wherein you can learn any concept in 2 sessions. So please do make sure that you follow this network analysis crash course playlist, and follow our network analysis playlist also. If you want more and more problems, ನಂಗೆ ಒಂದು ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಮಾಡೋಕ್ಕೆ ಕಮ್ಮಿ ಆಯಿತು, ಇನ್ನೂ ಮಾಡ್ತೀನಿ ಅಂದರೆ ನನ್ನ ಪ್ಲೇಲಿಸ್ಟ್ ಅನ್ನು ನೋಡ್ಬೋದು. ಇಲ್ಲ ಅಂತಂದರೆ, ಇಫ್ ಯು ವಾಂಟ್ ಟು ಲರ್ನ್ ಅ ಕಾನ್ಸೆಪ್ಟ್ ವಿತ್ ಇನ್ 2 sessions, ಯು ವೆಲ್ಕಮ್ ಟು ಡೂ ದಿಸ್. Okay, welcome to watch this. Okay, so the general diagram is as follows. So wait a minute, I'll write it completely. Okay, now, and you have a question based upon, say, write the steps to how to solve mesh analysis, and they'll be having a question. So please do make sure that you also see through that question. It is very important. He'll ask you what are the procedures or steps to be followed while solving a mesh analysis for some marks, some good marks only. Okay, so that one I'll be sharing it to you in the community section. So please do make sure that you look at that and practice it without fail. Fine. Okay. I'm sorry for the distraction. Okay. So this is what is the general diagram for mesh analysis. I have already discussed this, but why I'm discussing this again is because as I'm handling a network analysis crash courses, and as I'm teaching you all this, I have to teach you all this here, because I'm already telling you that you can learn any concept in 2 sessions. So that is why I'm just redoing this again. You also have the same in your ಮೆಷಿನ್ ನೆಟ್ವರ್ಕ್ ಎನಾಲಿಸಿಸ್ ಪ್ಲೇಲಿಸ್ಟ್, ರೈಟ್? ಸೊ ಬಹಳಷ್ಟು ಜನಕ್ಕೆ ಅಷ್ಟೊಂದೆಲ್ಲ ನೋಡೋಕೆ ಟೈಮ್ ಇರಲ್ಲ, ಕಡಿಮೆ ಟೈಮ್ ಇರುತ್ತೆ, ಪ್ಲಸ್ ಅಷ್ಟು ನೋಡ್ತಾ ಕೂರೋಕೆ ಡೀಟೇಲ್ ಆಗಿ ಆಗಲ್ಲ. ಸೊ ಅಂಥವ್ರಿಗಾಗಿ ಇದನ್ನ ಮಾಡ್ತಾ ಇರೋದ್ರಿಂದ, ಸೊ ಹ್ಯಾವ್ ಟು ರೀಡು ದಿಸ್ ಅಗೇನ್. ಡೋಂಟ್ ವರಿ, ಇಫ್ ಎನಿಬಡಿ ಹ್ಯಾಸ್ ಸೀನ್ ದಿಸ್, ಇಟ್ಸ್ ಓಕೆ, ಫೈನ್. Okay, yeah. So this is V1 and V2. So now I have written the general diagram. I haven't marked nothing. So let us see the procedure one by one and apply the procedure to this general diagram. Fine. What I'll do, I'll tell you the procedure one by one. and I will apply the procedure one by one to this general diagram. So what is the very first procedure? So very first procedure says nothing but I'll tell you the procedure, and that the same I'll be updating in the community page. So please do watch it without it, because he'll ask you a question, say mention the steps or write the steps or procedure to be followed while solving a mesh analysis. Okay. Yes. Yeah. So make sure that your network given as a planar network, because mesh current analysis cannot be used to solve a non-planar network. So that means you need to make sure that whatever the circuit given to you to solve using mesh analysis is a planar network. So that means all the circuits which is given as a planar network only, whatever you get in a question paper, whatever you are solving currently is a planar network. It is not a non-planar network, because mesh analysis cannot be what? Mesh analysis cannot be solved for a non-planar network. I hope you got the very first step, right? You can already have a check, and it is like whatever the questions given to is a planar network only, so that you can just write it, but you already know that, right? Yeah. Okay. And all the nodes of the electrical circuit are named by letters, either the capital or small case, and identify the mesh in the circuit. All the nodes in the sense like you mentioned here. See, this is A, B, like C, D, and all. You mention it, right? So that is what is telling, that all the nodes of the electrical circuit are named either in capital letter or small letter. Okay, small case, to identify the meshes in the circuit. So this is what is you do. This has to be done. Actually, this has to be done. I'll do it. See, A, B. Why this has to be done? Why this has to be done is because if you just write mesh 1, mesh 2, mesh 3, the evaluator will not get to know sometimes, right? He'll be in a hurry to correct the papers. He's got lot of papers. Need to correct within 2 minutes of time. So that is why this is one good methodology. Mark the, what I can say, the notes. Mark the notes with the letters which is either capital or small cases, and that will help you identify your mesh. So let me mark that, student. So please wait. It is E, F, and okay, G and H. E, F, G, and H. Okay, now, yeah. So now I have marked that. So the third step is what? The third step is what is nothing but, if there are any practical current sources in the circuit, they are converted into practical voltage sources, and the source transformation methodology we had discussed in detail in the day before yesterday's session, Saturday's session. Okay. So what does that mean actually? For example, sometimes here you can see that I'll just say this E and G, I'll just showcase to you here. See, for example, if there is any, what I can say, a current given in parallel with a resistance over here. See, if the circuit is like this, if the circuit is like this. So now what you have to do? Can you just, what I can say, do the apply the mesh analysis procedure? No. Why? Because here there is a current in parallel with the resistance, and that has to be converted into voltage in series with the resistance. How does that look like? That look like there is an voltage present over here, and you have a resistance, right? This is what is you have to do if that kind of question comes into existence. In your diagram, if you have any current and parallel with the resistance, you have to convert it into voltage in series with the resistance. Remember, okay, so that is why they specifically told you if there is any practical sources, current sources in the circuit. So practical current source is nothing but a current source is in parallel with the resistance. So if there is practical current sources and that is practical current sources in the circuit, you have to convert it into practical voltage sources, right? Practical voltage source, you can keep it as it is, because that need not to be converted. That can be directly taken into consideration, and they can apply it for the circuit, mesh analysis for the circuit. Fine. I hope you got my point. How many points we learned? We learned first we need to check whether the diagram is a planar network or not, because your mesh analysis cannot be applied to non-planar network. That's the very first step. And the second step we learned, we are going to mark the each and every nodes of the circuit either in the capital letters or small letters, so that it is easy to identify the meshes. The third step, what we learned is that, so you have to find if there is any practical current source in the circuit, say which I have told you, that is this one. If there is any practical current sources, you are going to convert it into the practical voltage sources by using the source transformation methodology, and the source transformation methodology I have taught you in Saturday's classes. Please do watch it without fail. Fine, live classes. Okay, yeah. So now next thing, I'll just erase this because this is not needed right away. Okay, yeah. So the next next thing, what is that you're supposed to do is that the voltage sources and current sources, whether they're independent or dependent, whether they're in series or parallel circuit, they're represented by the equivalent voltage and current sources. This is very simple. And that you have any voltage sources or current sources in the diagram, whether it is independent or dependent. Dependent sources means this, right? These are the dependent sources. So this is your dependent sources, and what I can say, this is your dependent sources. You have how many dependent sources? Four. That is voltage dependent voltage source, voltage dependent current source, current dependent voltage source, and current dependent current source. You have all those, right? Those are the dependent sources. Whether your voltage or current sources is independent or dependent, whether they are in series or parallel, so it has been represented by the equivalent voltage or current sources, right? Yes. And the next step is what? Very important step. Any resistance or impedance in parallel with an ideal voltage source or in series with an ideal current source can be neglected. So this I've already told you. If you have any voltage in parallel with the this one, that is resistance, and what I told you, any current in series with the resistance has to be neglected, which I've already told you in the case of source transformation, right? Source transformation ಅಲ್ಲಿ ಹೇಳಿದ್ದೀನಿ ಕೂಡ, ಈ ತರದೊಂದು ಲೆಕ್ಕ ಮಾಡ್ತಿದ್ದೀನಿ ಕೂಡ, ದಯವಿಟ್ಟು ಚೆಕ್ ಮಾಡ್ಕೋಬೇಕು. ಓಕೆನಾ? Yeah, yeah. And then the next important thing is, the mesh currents are assumed arbitrarily in the either clockwise or anti-clockwise direction. We basically take it in clockwise direction, right? You know, it can be represented in clockwise or anti-clockwise, but we people take basically in clockwise direction. So it is your clockwise direction, this is your clockwise, and this is your anti-clockwise. It starts from here like this, right? We are taking it in clockwise direction, right? Okay. And the next thing is, the equation for the meshes are written using general mesh analysis equation as in the equation, right? So see here, I'll just tell you. So here you can see that this is clockwise direction that we are considering. Let me mention the currents as I1, and let me mention the currents as I2. Let me mention the current as I3. Fine. Okay. Now what is that going to happen is, you are going to write a mesh equation. So for writing a mesh equations, I have told you one very important thing. What is that? I have told you that if you have, say, what I can say, if you have what I can say, the voltage and the resistance. So for your voltage, you have to take it as, that as positive to negative was positive. Very important. Negative to positive was negative for your voltages. This is all for your voltages, and for your, what I can say, the this one resistance, it is always a positive. This is very important. I hope you are getting my point, right? Considering this one now, let us write the equation. Fine? Okay. So, yeah, so here you can see that I'll write first the equation. Let me just minimize. Okay. So, here it is V1. So, this is negative. The smaller one line is negative. The bigger one is positive. I hope you got it. Yeah. So, this is what, if you can consider. So here it is negative to positive, which is what? Negative. Negative to positive is negative, right? Negative to positive is negative, so that is minus V1. This is plus R1. Okay, so plus I1 R1, and this is plus R2 into I1 minus I2. Why R2 into I1 minus I2? Because I've already told you that if there is any resistance present between two of the meshes, so in between the two meshes, you have to subtract, you have to take the resistance multiplied by the subtraction of the two resistances current. That means this R2 is present in where? This R2 is present in where? It is present in I1 and I2. That is, it is present between I1 and I2 measures. And what is that going to happen is that you have to consider the R2. It is multiplied by the two resistances. That is the currents of the two resistances. You have to subtract the currents of the two resistance. That is multiplied by the subtraction of the currents of the two resistance, wherein the very first current is nothing but I1. Why I1? It is because we have considered what I can say the mesh 1. That is why we are taking I1. Then we have to subtract with the other mesh current wherein the resistance R2 is present. Right? ಇವಾಗ ನಿಮ್ಮ ಒಂದು ರೆಸಿಸ್ಟೆನ್ಸ್ R2 ಇದೆ. ಇಲ್ಲಿ ರೌಂಡ್ ಮಾರ್ಕ್ ಹಾಕಿದ್ದೀನಿ ರೆಡ್ ಅಲ್ಲಿ. ಈ R2 ಬಂದು ಮೆಶ್ 1 ಮತ್ತೆ ಮೆಶ್ 2 ಮಧ್ಯದಲ್ಲಿ ಇರೋ ಕಾರಣ ಏನಾಗಿದೆ ಅಂತ ಅಂದ್ರೆ, ಸೊ ಫಸ್ಟ್ ನೀವು R2 ನ ಬರೀತೀರಾ. R2 ನ ಬರದ್ಮೇಲೆ ಏನ್ ಮಾಡ್ತೀರಾ? You have to multiply with I1 minus I2. Why I1 minus I2? Because I1 ಬಂದು ಮೆಶ್ 1 ಕರೆಂಟು ಮತ್ತೆ ನಿಮ್ಮ R2 ಫಸ್ಟ್ ಮೆಶ್ 1 ಅಲ್ಲಿ ಪ್ರೆಸೆಂಟ್ ಆಗಿದೆ. ನಾವು ಫಸ್ಟ್ ಕನ್ಸಿಡರ್ ಮಾಡ್ತಾ ಇರೋದು ಮೆಶ್ 1 ಗೆ. ಸೊ ಹಾಗಾಗಿ your ಮೆಶ್ 1 is nothing but A B C D A. ಆಯ್ತಾ? have to write apply apply the KVL to A, B, C, D. Here we are making use of KVL. You know what is KVL, right? KVL is nothing but the, what I can say, the KVL is nothing but, okay, let's tell you about KVL. So see here, I hope you got this, right? Yes, so this is, first we are considering I1 mesh, so mesh 1, so mesh 1 current is I1. So that is why it is I1 minus the next, what is the next current? So the next current is I2, wherein R2 is present at mesh 2 also. So we are going to subtract with that current, and which is what I can say the plus, which is what I can say the is equal to 0, right? Or I can write it as I1 R1, or I can write it as I1 R1 plus I1 R2. Just a minute, I'm very sorry for the distraction, students. Okay, I'm very sorry for the distraction. So minus I2 into R2, which is equal to 0, which is equal to 0. So this is what is. Here you can see that you have I1, and I1 is common here. So that is what I can say. I1 you have to take it as common again. It is I1 into, that is what I can say the R1 plus R2 R1 plus R2 minus I2 into R2, which is equal to, which is equal to 0. Okay, so this is what is one important thing. This is what is the equation number 1. So yes, okay. So actually what is KVL? KVL is nothing but, so here KVL is nothing but, I just did not tell you that, I'm very sorry. KVL is nothing but the total sum of all the voltages in a closed loop circuit is equal to 0. That is, you're going to add all the voltages and you're going to equate it to 0. Wherein your equation will be say like V1 plus V2 plus V3 till Vn, which is equal to 0, wherein your V1 is equal to I1 R1, V2 is equal to I2 R2, V3 is equal to I3 R3, and V4 is Vn is equal to In Rn, right? I hope you know that. Okay, just forgot to tell you that, so that is why I just updated it later. I hope you got what I'm trying to do, right? There was some distraction in between, I'll just repeat it. So see here, you can see that this is minus V1. Why? Minus V1 is because, so I've told you that negative to positive for the voltage is always negative, and it is plus I1 R1. So what is I1 R1? So this is positive R1 into this current I1, and this is plus R2 into I1 minus I2. So what is I1 minus I2? So I1 minus I2 already told you there is a resistance R2 which is lying between the two meshes. So what is that you have to do is you have to first take R2, then multiply with the first current. So we are considering mesh 1, and here the mesh current is I1. So that mesh I am taking it as I1 minus what? It is minus I2. That is I2 is nothing but this mesh, second mesh. So wherein the resistance R2 is present, which is equal to 0. And now we multiplied all this and we just shifted here. I forgot to write V1. I'm very sorry for the distraction. Actually, there is some distraction in between, so I couldn't make it properly. Okay. So yeah. So here this is V1, and here also this is V1. Why V1 is because here it was minus V1, wherein we shifted to the other side. Fine. Out. Right. So that is why we got it as V1 over here. Just a minute. I'll just push it up. V1 over, V1 over here, okay, and here also we had I1 as common, so I removed I1 as common and I got this equation, number 1, right? In the similar way, I hope you understood how to do this. In the similar way, I'll write the other two equations, so I hope you can understand. So, wherein your other two equations is nothing but, so apply what I can say KVL to, that is what? Apply KVL to DC E, I forgot I let it, E and G. Okay. Yeah. It is DCEFD. This is DCEFD and this is ABCDA. ABCDA, DCEFG. Fine. Okay. Right? Yeah. So now let's apply for DCEFG. Sorry, DCEFD. Fine. Okay. I'll write DCFD directly. So ನೀವು ಬರಿಬೇಕು apply KVL to DCFD ಅಂತ. So when you write that, what is that you're going to get it as? That is, first you're going to get it as, please to see here, it is R2 into I2 minus I1, because now we are considering mesh 2. That is why we are giving priority to mesh 2, wherein it is R2 into I2 minus I1 and plus R3 into I2, once again plus R4 into I2 minus I3, because we are giving the first priority to the mesh 2, so that is why we are taking mesh 2 minus mesh 3. I'll write that. Okay. Yeah. So it is nothing but your R2 into I2 minus I3 and it is what I can say plus R3 into I2 plus R4 into what I can say the I2 minus I3, right? So now if I simplify this, I can directly write it as, so it is R2 I2, so ಇಲ್ಲೇನಾಯ್ತು, ಇದು R2 I2 ಆಯ್ತು, ಇದು minus R2 I3 ಆಯ್ತು, and here it is minus R4 I3 and here it is R4 I2. So what I can do, and here it is R3 I2 as you can see here. So what I can do, I can directly write it as I2 into, that is I2 into R2 plus R3 plus what I can say R4. How did I get? I'll tell you. Please wait. Yeah. So this is R3 I2, right? And this is here, if you multiply R2 into I2 get R2 I2. Here if you multiply R4 into I2 get R4 I2. So therefore what is that going to happen is that, so I can take I2 as common in all the three. I get R2, R3 and R4. Fine. Plus, so I have I3 into, so what I have plus, so I'll write it. See here, you have minus R2 I3 and what I can say minus R4 I3. Howda? So if you can take I3 as common there, minus I3 into, you can take it as R2, what I can say, minus R4, right? You can take it as R2 minus R4, right? I'll just write it. So please wait for a minute. Okay. So this is I1 students. I'm very sorry for the distraction. Yeah. There is some distraction happening in between here. That is why I couldn't make it up properly. I'm very sorry. So here it is R2 I1 here. R2 I1. Okay, and this is minus R4 right here. This is proper, which is equal to 0 because you don't have any voltages, right? That is why I just made a check while doing it. Okay, so please to sustain. Okay, yeah. And the next thing is I have to take for which one? I have to take for the mesh, that is apply KVL to mesh FEGHF, right? F E G H F. F E G H F. So if I take for that, I'll just write the equation. As you all know, it is R4 into I3 minus I2 because first we are taking mesh 3 and the mesh 3 current is of first priority, right? I3 minus I2 and R5 into I3 and R5 into plus R5 into I3, that is what I can say here. What I can say, it is plus V2 which is equal to 0. Why? Because here you have the positive to negative. Positive to negative, which is positive. So that is why here it becomes plus V2 which is equal to 0. And the sign convention has been shown in the VTO scheme of violation only. If you can see the problem and their answer, you can see that they have used this sign convention only without fail. Okay, now? Yes. So if I can write that, so I get the equation as, what I get the equation as, so I get the equation as what I can say, apply KVL to the equation, to the mesh FEGHF. So you get it as, that is your R4. I can directly write it as I3 into R4 plus R5, yeah, because I have R4 I3 and R5 I3. That is why directly write it as R4 plus R5, yeah. Okay. Then I'll write it as minus R4 I2, which is equal to, I can write it as minus V2. Why minus V2? Because I have positive V2 over here. Positive to negative is positive V2. That positive V2 will come to the other side, so it becomes minus V2, right? I hope you got it. This is what is the equations. Put it in your calculator. This is equation number 2. And this is 3. Put it in a calculator and get the resultant for this particular. Okay, so according to the value, get the resultant. There are tips and tricks for this also. That one we are going to see through the problem itself, which is going to take place on Friday session, right? Okay. And super mesh analysis, what is that going to happen is that, so you have a current between the two meshes. Like for example, let me just write a general diagram for that. So here you can see that there is a mesh over here and there is a current over here. I'll just write diagram in a simple manner. All the procedure is the same, students, nothing. Okay, yeah. And here this is. So say this is my diagram, a simple diagram, wherein I have an voltage over here, I have a current over here, I have resistance R1, R2 and R3. Say here what is that going to happen? You can see that there are two meshes present. This is one and mesh and this is one mesh. So what is that going to happen? I can see that in between these two meshes there is one current present. So there is one current present and that current I call it as a super mesh current, right? And this mesh is called as a super mesh because there is a current in between the two meshes and you have to only what I can say, take up two equations wherein one equation is for one single mesh and the other equation is for a super mesh, right? Two meshes clubbed together to form a super mesh because there is a current in between two meshes, that is this is called as a super mesh. And for this two meshes you have to take one equation, and for the other mesh which is separate mesh that is not included in super mesh, for that you have to construct one equation. So two equations. Here you can easily reduce the equation from 3 to 2, right? Yeah. and the procedures are all the same. All the procedures are the same. What is that going to happen is the equation is reduced to 2 because there is one current which is being present between the two meshes, right? I hope you got today's session. In today's session, we'll learn what is a mesh. So what is a mesh? Mesh is a closed loop, and also what I can say, a mesh is an electrical circuit wherein it's a closed path also. Also, it is also called as a loop wherein there is no other loop present inside that particular loop, right? And we also discussed what are all the, I'm sorry, please wait. Yeah. We have also discussed what I can say, what are all the process for the mesh analysis. That is, you need to check it whether it is a planar network or non-planar network, because mesh analysis is applicable only for planar network. And we have told you have to mark all the nodes with the letters, whether it's a capital or small. See, I have marked all the nodes with the letters, it's capital or small, so that you can easily identify the meshes. And then the third step we learned is nothing but, so if there are any practical current sources in the circuit, you need to convert it into voltage source. I showed you what is that. And the fourth step we learned is whatever the current or the voltage sources you have, which is independent or dependent. I told you what are the dependent sources also, and independent and dependent, and they are in series or parallel. So they are represented by their equivalent voltage or current source. And the next step we learned is nothing but, any resistance or impedance in parallel with the ideal voltage. I showed you, right? So resistance in parallel with the voltage or resistance in series with the current are neglected, I have told you. And the sixth step that we learned is we are going to assign the mesh currents in the clockwise direction or anti-clockwise direction in our syllabus, or what I can say in general we make use of clockwise direction only. And the seventh step we have discussed with respect to that is the mesh currents. What I can say, the equations of the meshes are written in the general form, right? General mesh analysis you're going to make use of, or I can say KVL we make use of to write the mesh current equations, right? Okay, and the mesh equations are solved using Kramer's rule or any other method. After solving this, if you have complex numbers, that is j, that is like say 10j or 10i. So then what is that going to happen? You have to make use of the Kramer's rule, because in your calculator this doesn't work out, right? ನೀವು ಏನೇ equation ಗೆ j ಕೊಟ್ಟರು ವರ್ಕೌಟ್ ಆಗಲ್ಲ. So Kramer's rule ಬಳಸಬೇಕಾಗುತ್ತೆ. And once the mesh currents are calculated, the branch currents also can be calculated. So these are all the steps that we learned today. And we learned what is also super mesh. Super mesh is nothing but what is that going to happen is that, so I'm sorry, if you have any currents, what I can say, present in between the two meshes, you can see there are any current present in between the two meshes, so that is said to be a super mesh. So that you have to consider the, what I can say, the super mesh, what I can say, the equation. So this is what is your whole super mesh equation. And one more thing to remember, that you have to construct two equation properly, and the third equation is nothing but you have to construct for the current. That means the current is present between these two meshes, and you need to write the equation for that current, that is I3 minus I1 is equal to 10 ampere, or I3 minus I2 is equal to 10 ampere. Like that we are supposed to construct. Okay, and we have also discussed with respect to the sign convention, that is negative to positive was what I can say, the negative, and positive to negative is positive for all the voltages, and for all the resistances it is positive, we have discussed. So that one you have to follow, and I told you how to construct an equation, and you have to write applying KVL for the meshes. So why we have taken the very second step, that is all the nodes of the electrical circuits are named by letters, either capital or small letters, so that you get to know the meshes, right? You will get to know the meshes easily, and you can write the name of the meshes so that the evaluator can get it easily. So this is what is for today's session, and I'll take one important problem for you, one or two important problem in the Friday session. I'm telling you, I'll be taking the session on Friday. Friday session ಅಲ್ಲಿ one or two problems ತಗೊಳ್ತೀನಿ. ಅದರಲ್ಲಿ ನಿಮಗೆ ಕೆಲವೊಂದಿಷ್ಟು ಟಿಪ್ಸ್ ಆ್ಯಂಡ್ ಟ್ರಿಕ್ಸ್ ಅನ್ನ ಹೇಳ್ಕೊಡ್ತೀನಿ. ಇವಾಗ ಆಲ್ರೆಡಿ ಹೇಳ್ಕೊಟ್ಟಿದ್ದೀನಿ. ನಿಮ್ಮ ಒಂದು ಸೈನ್ ಕನ್ವೆನ್ಷನ್ ಒಂದು ಟಿಪ್ಸ್ ಆ್ಯಂಡ್ ಟ್ರಿಕ್ಸ್, ಮತ್ತೆ ನಾನು ಮಾಡಿರುವಂತಹ ಒಂದು ಈಕ್ವೇಷನ್ ಟಿಪ್ಸ್ ಆ್ಯಂಡ್ ಟ್ರಿಕ್ಸ್. ಇನ್ನ ಒಂದಿಷ್ಟು ಹೆಚ್ಚು ಅಂದ್ರೆ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಎಲ್ಲೋ ಒಂದ್ ಕಡೆ ವಿ ಕೊಟ್ಬಿಟ್ಟಿರ್ತಾರೆ, ಎಲ್ಲೊಂದ್ ಕಡೆ ಐ ಕೊಟ್ಟಿರ್ತಾರೆ, ದಟ್ ಇಸ್ ಮೇಕಿಂಗ್ ಯು ಕನ್ಫ್ಯೂಸ್ ಅಂತ ಲೆಕ್ಕ ತಗೊಂಡ್ ಬಂದು ನಿಮ್ಗೆ ಟೀಚ್ ಮಾಡಿ ಟಿಪ್ಸ್ ಅಂಡ್ ಟ್ರಿಕ್ಸ್ ಮಾಡಿ ಕ್ಲಿಯರ್ ಮಾಡ್ಕೊಡ್ತೀನಿ. ಸೊ ದಯವಿಟ್ಟು ಈ 2 ಸೆಷನ್ ಫಾಲೋ ಮಾಡಿ, ತುಂಬಾ ಚೆನ್ನಾಗಿ ಮೆಶ್ ಅನಾಲಿಸಿಸ್ ಗೊತ್ತಾಗುತ್ತೆ ಅಂತ ಹೇಳ್ತಾ, I'll just wind up this session, students, and please do watch all my videos and like, share and subscribe and share it to your friends so that it helps you a lot ಅಂತ ಹೇಳ್ತಾ, Thank you, students.